Are we holding prices constant? So let me say probably not, and let me show you how we can do this. All right. So let me show you how I'm going to make this work. In other words, what I held constant here to here was not. I held the quantity of cars constant. Think of it that way, right? I held cars constant. So let me think about a demand system, right? So let's think about. I got X gas, which depends on the price of gas, price of cars, a bunch of other stuff, right? And I got X cars, depends on the price of gas, price of cars, a bunch of other stuff, right? So this is XG, XC, right? That's the way I'm thinking about my equilibrium, right? I'm thinking about my equilibrium as the quantity of gasoline consumed depends on the demand for gas. The amount of cars consumed depends on this, right? So the long run, partial XG, partial PG, long run is just equal to partial X gas, partial P gas. That's it. The long run response says hold prices constant. How does the quantity of gas respond to its price when people can freely adjust all the other goods? And importantly, freely adjust their cars. Okay? Now, how could I use these demand curves to talk about a short run effect? Okay? So what I'm going to say is different about the short run is I'm not going to let people change the quantity of cars. Right? I'm going to assume that rather than being able to buy as many cars as they want at the fixed price, that in fact the quantity of cars is held fixed in the short run. Right? That is, the fleet of cars is the same tomorrow as it was today. Right? So how would I do that using these demand curves? Well, how is it in a market economy I could hold the quantity of cars fixed as the price of gas goes up? Price of gas is rising. People are going to say, geez, I want fewer cars. I'm going to try to sell my car. So in that market, what's going to happen to hold the quantity of cars constant? Well, think about it. What am I going to have to do in that economy to keep the quantity of cars where it was? People want fewer of them. I'm going to have to reduce the price of cars. I'm going to have to make cars cheaper to make people want to hold them. Right? So what I'm going to get dxg short run equals partial X gas, partial P gas, plus partial X gas, partial P cars, dP cars. Right? So that's going to be the first equation because I'm going to let the price of cars move. Remember before I was holding the price of cars constant. Now I'm going to let it move. And then for the car equation, I'm going to get 0, right? Because I'm not going to let the quantity of cars change. It has to be equal to the price X cars, partial P gas, plus partial X cars, partial P cars, dP cars. So the price of cars is going to have to adjust so as to hold the quantity of cars fixed. Okay? So that's going to imply dP cars is equal to minus X cars partial price of gas divided by partial X cars partial P cars. Okay? So what does it say? Well, if cars are complements for gas, then as the price of gas goes up, I want fewer cars. Right? So this is negative. This is negative by the law of demand. And this is negative because it's a minus sign. So 3 negatives make a negative, which says, lo and behold, the price of car is going to have to go down, which is what we said. Price of car is going to have to fall to induce people to hold the same stock of cars they had. I can then substitute that in here, and I get dxg x gas short run equals partial x gas partial p gas minus partial x gas x gas partial p cars times partial x cars partial p gas divided by partial x gas partial p gas. All right? So now, remember before, this term is negative, right? This is the own price long run effect. So that's a negative term. What's the sign of this second term, including the minus sign? Well, this one's negative, this one's negative, this one's negative, and this one's negative. 4 negatives now. 4 negatives makes a positive. So that means that this short run effect is going to be smaller than the long run effect. Right? Because it's going to be muted by this second term. Right? It's going to be muted because as the price of gas goes up, people want to buy fewer cars, but the price of cars is going to go down, which is going to induce them to hold more cars than they otherwise would, which is going to hold up the demand for gas. Right? Demand for gas will stay up because people are still consuming as many cars as they were before. Right? People understand how that works. So that's the basic mechanism by which this short-run demand is going to be less elastic than the long-run demand. Okay. People understand that? Yeah. What? Go ahead.
Is there a typo? I mean, could be the denominator could be the car, X car.
Oh, I'm sorry. This should be X cars. Sorry. It's not a typo. It's a random notation. Cars. Yeah. Those should have been cars and cars. Still the same sign, still negative. So that's kind of the point. It's going to be, this whole term is going to be positive. All right? Any questions? Yeah?
Does that only work if you can close that curve to come to, on the top diagram, you come back to the initial?
No, that's just saying that this curve here is steeper than that one.
When it drops down again, you may not be on the same long run curve, you may shoot past that.
Well, it won't generally shoot past it. Generally, most stories people tell are reasons that you would come up short.
Okay.
Because you're not going to rebuild everything you had before. There's going to be some permanent changes that are not going. You will have made some adjustments to conserve gas that you won't. Now, the key point was you actually might go past it for the reason I talked about. You became more efficient. And when you became more efficient, you could actually now produce higher performance. And you might have such an elastic demand for performance that you actually consume more gas than you would have before. You could actually go past for that reason.
I'm saying if you can't close the curve, those partials may not work out.
Well, these partials, think of it as at a point. The partials are right around that point, saying that curve is steeper than the other one. That's kind of what the partials are working at. Yeah?
Where are we using that savings when you start these peaks?
We used it here. That is, when we calculated how much the price of cars had to change, we did that in order to hold the quantity of cars fixed. That was the trick. We said, rather than hold the price of cars fixed, which is the usual way we look at demand, let's think about holding the quantity of cars fixed. Now, we can do that because we could just say, well, price has got to adjust enough so as to hold the quantity fixed. That's kind of the intermediation. Now, in the real world, what would happen is actually not all cars would get cheaper. Fuel-efficient cars might go up in price, and gas guzzlers might get cheaper. That is, you might have things that are substitutes for gas, not complements. But it turns out that goes the same way. Because what if I looked at what would be different if this other good was a substitute rather than a complement? What would be different? Well, this term would be the opposite sign. This term would now be positive. But if this term was positive, that term also would likely be positive. That is, they would be substitutes both ways, and the result would still follow. Right? Because it would be minus, 1 minus, 2 negatives, and now 2 positives. So as long as the cross partials are the same sign, that is, when one's a complement for the other, they're complements in the other direction, or substitutes and vice versa, you're going to have this effect that it's going to be more elastic in the long run than it would be in the short run. Because basically what's going to happen, the price of this good goes down. You try to buy less complements, makes complements cheaper, which preserves the demand for this good. You try to run and buy more substitutes, they get more expensive, which also preserves demand for this good. Right? So whether it's substitutes going up in price or complements getting cheaper, the net effect on this good is always the same. It reduces your ability to get away from this good. Right? Everybody understands? Yes?